Hi and welcome to GeeksforGeeks. I'm Siddharth Hazra and today we would be discussing three-way partition. So in this problem, you are told that you are given an array, and what you're told is you are also given A and B. And what you really need to do is all the elements which are less than A should be here, and all the elements which are in between A to B should be here, and all the elements which are greater than B should be in the end. So let's see the very first example itself. We have 1, 2, 3, 3 and 4, and the value of A and B is 1 and 2. So all the values which are less than 1 should come at this side. So we don't have any values less than 1, so it's fine. This part would be now from 1 to 2. What are the values? So we have 1, we have 2, and then all the values which are greater than 2. Okay, so greater than 2 we have 3, 3, 4, but we can also write 4, 3, 3. This is a small thing. Like, this is very important. Like, either of the permutation combination would be accepted. You just need to respect these conditions. Like here it might happen that yes, 4 is greater than 3 and it might come first, and that is not an issue. So whenever you need to sort basically three types of elements, whenever we talk about three types of elements, like we have 0, 1 and 2, we are given an array of 0, 1s and 2 and we need to sort them. There are three types of elements. Here also there are three types of elements. The very first type 1 is which is less than A. The very next type is which lies between A to B. And the very third type is which is greater than B. Okay. So the very simple solution would be that we would simply sort the given array. We would simply sort the given array, and as the elements are big enough, that is 10 to the power 6, we can't use counting sort or something. So we would simply use merge sort or quick sort, and the time complexity would be n log n. Okay, but can we do this in better than this? Yes, what we can really do is we can prepare three arrays. Okay, array which is A which is less than A. Okay, so now let us see. You can prepare three arrays. Okay, so this would be less than A, this would be between A to B, and this would be greater than B. So less than A, so this value is not less than A, so we won't do. This value is between A and B, this would be inserted here. Okay, then the very next value is 2, which is also in here. The value is 3, which is greater than 2, that is A is equal to 1 and B is equals to 2. So it is greater than 3 is greater than equal to 2, so it would come out here. Then we have again 3, so it would come out here. Then we again have 4, it would come out to be here. And then we can again keep back the elements in one after other, and that would solve the purpose. And this is feasible enough if you ask me. But the problem is, if this is given an online judge, this would be a flawless solution. But if you answer this in an interview, this is not as optimized. Why? Because first you are iterating over all the elements, and then you are again unpacking them and keeping them at their own position. So the space complexity is big O of n, and the time complexity is big O of n. I know, but you are iterating the same array twice. So the point is, the interviewer would ask you is, if he wants to kind of have the solution he wants, he would try to ask you, can you do this in just one iteration and without using this extra space? He would ask you these two things. Whatever be the requirement, you can't move forward with this. Okay? So whenever you need to sort the array based on three types, either it is 0, 1s or 2s or these three, the only thing that should trigger in your mind is, and this is absolutely non-intuitive for me, I don't know about for anyone else, but for me it was non-intuitive. So the first thing that should strike in your mind is Dutch national flag algorithm. So if this name seems weird or hard to remember, you can just simply ignore it. Just remember that this is something a flag algorithm, and our flag, like not our, okay, like India's flag, like most of you are Indians, and Indian's flag is composed of this kind of thing. So you can just remember that yes, this has a resemblance with the flag thing. That is it. So what does Dutch national flag algorithm tells us? Dutch national algorithm tells us that we would have a low which would be less. We would have a high which would be here. Okay? And we have something known as mid. Okay? Now, what it would try to do? It would try to have all the values which are greater than high here, and all the values which are less than L here, and all the values which are between L and H here. And the point is how it would be done, Siddharth. Let us see this. So let's say the array is, I would just modify a bit the second one. Okay, let's say the array is 1, 4, 3, 6, 2 and 1, and the value of A is 2 and the value of B is 3. Okay, now see this thing. So initially this is low, this is high, and this is the mid. Okay, what would happen? So see, so the very first value, that is 1, this value is less than A, so its position should be before low. Its position, all the values which are less than A should be before low. This is less than A, this is A to B, and this is greater than B. So if the value is 1, it should be before L. So what would happen is, we would simply swap the values of low and mid, as they both point to the same thing. The swapping won't make a difference, and then this low should move forward, because it should be happening this, and then this mid would also move forward. Like after successful swapping, if it is swapping with L, L should move forward and mid would always move forward. Now this value is 4 and it is greater than B, so its value, its place is after H. So we would swap 4 with 1, and then H should come here, because a value greater than H should lie here after the high. So we would swap this. This would become 4, and this would become 1, and then this would become high. Now in this point, bid won't increase. Why? Because it might be a scenario that here at high, a bigger value, let's say 6 was there, which came here. So let's say if this value was 6, it would have been came here. Okay, and here we got 4. This is fine, but again this 6 needs to be again here. That is why this time whenever we replace it with high, the mid won't move. Whenever we replace with low, it would move. Why? Because it is less, so that place is there. Okay. But in the case of high, it needs to be considered. Okay. So now again we would see 1. It is less than A. So it would just swap again L and mid. This would be the same thing. So mid would move forward. Mid would move forward. And L would also move forward because all the values which are less than A should be at that. Now again we have 3. And 3 lies between A and B. Okay. So only mid should increase at this point. Mid is increasing at this point. Now again we have 6. So this time it should replace again. Okay. So again this time we would have here 2, and here we would have something as 6. Mid won't move forward. High would move forward because all the values which are greater than B should be after high. This is the objective. Now, the low and high, again we would compare 2. It is less than equal to the value. So now this time, if it is in between A and B, only mid would increase. If it is less than L, then L would be swapped with L, and this time mid would increase. And this time only high would decrease after swapping. Why? Because it might be a scenario that a high value came at this point, which won't be considered if mid goes forward. Okay, that is why we won't move the mid forward. Now, after this, if it is in between A and B, mid would increase. So after this, mid increased. So now mid surpassed high. So there is no point in doing anything. So now if you observe that less than value 2 is here, and 2 to 3 is here, and 6 and 4 is here. And this is just done by one iteration. First thing. The very next thing is that the space complexity is now constant because we are just taking 3 pointers. So now this is again the same kind of implementation. So I would explain you the code itself. Now see, first we are just having low 1, 2, 3, 4, 5. I would just explain you everything. So initially this is equal to low, and this is equal to mid, and this value is made as high, so that this thing happens. Now till mid is less than high, whenever mid would surpass high, there is no point in doing that. Just told you. It is low. If it is low, so what would happen? We would swap and mid plus plus. So we are swapping mid plus plus, and low would always increase. Low would move forward. If it is greater, high would decrease, but mid won't move forward. Why? Because let's say a high value 6, after swapping, it came here. That is why, the reason. So swapping would definitely happen, high would decrease, but this would happen. And if it is within the range, it would simply move forward because the value is less than this is meant to be here. So this is the Dutch national flag algorithm. Now let us see if this is working or not. Now let us try to submit this and see. And yes, this is working. And yep. So by the way, a quick suggestion, the last 2 videos of mine contained only the explanation of the solution. So what I'm thinking is, instead of coding it live in just C++, I would start explaining the code which is already pre-written in all the 3 languages. I would cater C++, Java and Python, because I can't code it live for like on all the 3 languages. So you just do a poll on your end what you need. Like, you want me to explain just C++ and doing live coding, or you want me to cater all the three languages by explaining you the code and doing the drive, which is more important, I think so. Like if you ask me, my personal recommendation would be to move forward with the second one so that a larger audience could be catered, this work could be justified, and a dry run proves to be of better understanding than just mugging up the syntax. So that's my personal take. You are the audience, you are the deciding factor. You all can give your views on this. So this was Dutch national flag algorithm. If you are a person who has not sought an array of 0, 1s and 2s, consider solving this problem. Interesting one. That's it for today. Thank you and have a nice day.